Today we'll be talking about the TypeScript programming language, and we'll be giving a brief history and introduction. We'll also be talking about the features of the language. We'll also give you a presentation on the demo code, and we will be talking about the positives and negatives of TypeScript, as well as the uses in modern day. To get straight into it, we'll be talking about what TypeScript is. TypeScript is a superset of JavaScript, meaning that all valid JavaScript code is also valid TypeScript code. TypeScript just basically adds features on top of JavaScript without necessarily removing or breaking the original code or language.
Developed and maintained by Microsoft in 2012 by Anders Healsberg, it was made to allow for easier maintainability of larger code bases. Because unlike JavaScript, which you can only find the errors at runtime, TypeScript allows for errors at compile time, making it easier to maintain and to debug. And unlike languages that we know about like C++, which compiles into machine language, as TypeScript is a superset of JavaScript, it'll compile into JavaScript. Some of the reasons that TypeScript was invented.
So basically, TypeScript was invented because of JavaScript's limitations for large-scale development. JavaScript is dynamically typed, meaning you don't declare variable types, and the type is determined at runtime errors. TypeScript was basically designed to add optional static typing to JavaScript, which means you can catch errors at compile time instead of runtime. So basically, one of the major features of TypeScript is static typing, meaning that the variable types are known at compile time and not at runtime. And this helps you catch bugs before the code runs. And in TypeScript, typing is optional. You can choose how strict or loose you want to be, which in general just enhances maintainability and ability to understand and document the code.
TypeScript also allows for better tooling and IDE support, meaning it will run with most modern IDEs and allow for their utmost efficiency, making the life of a coder just a lot easier than running with some older IDEs and older languages. With TypeScript having the better tooling and the compile time error finding, it allows for a lot better scalability for enterprise level projects, allowing you to maintain and easily work on large code bases rather than being stuck with something like JavaScript where you'll have to run the code every time to find the errors. Key features of TypeScript include.
So one of the key features of TypeScript would be static typing. TypeScript basically allows you to declare the types of your variables and function parameters or return values. And this helps you catch errors at compile time rather than runtime. And some of the uses of static typing obviously would be, catching errors at compile time. And it also helps to prevent bugs by checking, the types before running the code. And it's especially useful in large applications where the runtime errors can be costly. It also just enables better tooling and IDE support and just helps developers code faster with fewer errors. Another key feature of TypeScript would be type inference, which obviously from the name, TypeScript can automatically just infer the type of variable that you want to use, even if you don't explicitly declare it. And a use of type inference would obviously be to reduce the need to manually declare types, because TypeScript is smart enough to figure out the type for you in many different cases. And type inference also just works hand in hand with static typing. You can use type inference where it makes sense and declares types explicitly when needed. And it just overall improves the developer experience. You still get the benefits of static typing without necessarily having to write all the type annotations manually.
Another great thing about TypeScript is interfaces. You can think of them like classes from C++. It allows you to give a variable or type a certain key details about it. A good example would be like a driver's license. You could have a interface that's the driver's license with it having the types, ID, issue date, and name. And it'll only, if the program uses this interface with static typing and the custom types, it'll only accept a driver's license if it has all those data fields filled out. Along with that, it has the strong IDE support, as mentioned before, where it'll allow for auto fill in, which basically means like a IDE like Visual Studio's code, will allow it to automatically fill in the code where it predicts what you're trying to type. It also allows for inline error reading. So while you're typing, if there's an error, because we all miss those semicolons, to automatically tell you. And then one of the key features of TypeScript is the compile time error checking. As we've mentioned before, it just allows for quicker error finding compared to JavaScript, and just it makes the life of the coder 10 times easier. Some of the features that we'll look at of TypeScript is the comparison of TypeScript versus C++.
So I'll basically be talking about the giving a comparison between TypeScript and C++ to really like the key features of the two languages. A key feature would be the typing system. For TypeScript, there's static typing with type inference, and TypeScript is a statically typed language, but it infers types when possible, which makes it flexible. And developers can also declare explicit types for variables and function parameters and whatnot. And in C++, it is also statically typed, and it requires explicit type declarations for most variables and functions, but the key difference is both are statically typed, but TypeScript allows for type inference, where C++ generally requires explicit type declarations. Another key feature would be the compilation and execution. TypeScript is, compiled into JavaScript before it is run in the browser or Node.js. It can run in any environment that supports JavaScript, such as web browsers or server-side environments. But as for C++, it's compiled into machine code, and C++ is, compiled directly into machine code or native code for execution on the operating system. The key difference between these two would be TypeScript is obviously compiled into JavaScript, and C++ is compiled directly into machine code, giving it high performance. But there's limited cross-platform portability unless you compile. Another key feature would be memory management. Obviously, TypeScript runs on JavaScript, which uses automatic garbage collection to manage memory, so developers don't necessarily need to manually allocate or deallocate memory. Whilst in C++, there's manual memory management, meaning C++ provides control over memory allocation and deallocation. And obviously, this can lead to more efficient use of memory, but also requires careful management to avoid memory leaks. Another feature would be the paradigms. Both TypeScript and C++ supports multiple programming paradigms. The paradigm supported by TypeScript obviously would be object-oriented programming. You can use classes and interfaces, and there's inheritance. And there's also functional programming. TypeScript supports functions as first-class citizens or whatever. And for C++, it also supports a multi-paradigm approach, but it obviously emphasizes object-oriented programming and procedural programming. And like I said, object-oriented programming, for C++, it has a robust system for classes and inheritance and like procedure programming. This means like you can basically write code in a series of instructions and functions. Another key feature would be the learning curve. Obviously, TypeScript is going to be generally easier for developers who are already familiar with JavaScript because, as we've said in previous slides, TypeScript is a superset of JavaScript. So if you already know JavaScript, TypeScript is going to be really easy for you to pick up because it just adds type safety and other features without necessarily changing the core structure of JavaScript. But for C++, obviously it has a steeper learning curve, especially for beginners because of its low-level nature and its complex features like obviously memory management, pointers, and manual resource control can be confusing for new developers because also C++ is a very powerful language which requires a strong understanding of how the operating system really works. Another feature would be the use cases between TypeScript and C++. TypeScript is mainly used for web development. It's widely used for like building large-scale web applications and server-side development, like backend development in Node.js and all that. The C++ is mainly used for system programming and game development. C++ is like the go-to language for building high-performance games. And for system programming, it's used in building operating systems that, need direct hardware access and performance. Another key feature, obviously, would be the runtime. And it just goes back to what I've said about the compile time, the compilation time and everything. TypeScript is compiled into JavaScript before it's run into, browser or Node.js. So, it can be run in any environment that supports JavaScript, such as web browsers or, Node.js, whilst C++ is, compiled directly into machine code and it's, run in a OS native environment, compiled executable. So I think these are the key features between TypeScript and C++, or the key differences between TypeScript.
To use TypeScript, for this example, we're going to be basing this off of VS Code. You're going to want to open up VS Code and press Control tildes. This will open up the terminal, and in the terminal you're going to type npm install-g TypeScript. This will install the necessary files for the IDE to run TypeScript. Once it's all installed, you're going to create a new file and call it helloworld.ts. This is going to be your main file that you'll write your TypeScript code in. Once you have written your code, you'll open up the terminal again and type in tsc helloworld.ts. This is going to compile your TypeScript file into a JavaScript file. This JavaScript file is going to be your main file that will run. Using node helloworld.js in the terminal, you'll run the JavaScript file and your code will function. If for some reason the file does not run, it most likely means that you do not have Node installed. To install Node, you'll just open up your browser, type in node.js, and search the download. Go to the site, download node.js, and then it should work. To edit the way the code compiles, you'll want to create a file called tsconfig.json. This will allow you to manage the way the IDE compiles your TypeScript file into the JavaScript file. Some of the syntax that we'll look at for TypeScript is...
So we'll be giving a brief overview of these TypeScript syntax. And the first thing we'll be going over would be the inferred type. And in TypeScript, you can explicitly set a type, or the compiler can infer the type automatically. based on the assigned value. And in this example, we have here let name John, let name name is inferred to be a specific string literal type John. The compiler automatically infers that name can only ever have the value John because it was assigned that value during initialization. This means that if you later try to assign something else to name, TypeScript will throw an error. And basically, this is an example of literal types. TypeScript doesn't just infer it as a string, but it narrows down to the exact string value, meaning name can only be John. The second thing we have is explicit types or non-inferred types. And in the example, the type of variable title is explicitly declared using string. And here, TypeScript is told directly that the variable title must be a string. You could change the value of title to any valid string, such as like Fortnite, and like TypeScript will still allow it as long as it is a string. Uh, this is explicit typing, where you manually specify the variable's type.
Once you have your types, you can use console.log to print them out onto the console, which is the same thing as using cout in C++. You can also put in numbers or your own string constant if you wanted to. We can also see the use of interface here, as earlier described. This interface is used using user to describe, or it describes user with a name literal and an ID literal. We will see more uses of these syntaxes in the demo.
Okay, so we'll be talking about the demo code. And I'll first talk about the first part, which is the define an interface part of the code. And basically here we just define an interface named user, and this interface specifies the name of an object, meaning any object that implements this interface must have two properties: the name, which is a string, and an age, which is a number. It ensures that whenever we create a user, it will also have two properties with the correct type.
Looking at this at the C++, you would be using structure with the name defining it being user as well. We will define the variables in user as name and age, assigning string to name and int to age.
For the second part of the TypeScript code, we'll be talking about the function that takes a user and returns a greeting. And then from the name, it's pretty clear that there's a function declaration and there's a function named greets, which takes an arguments user of type user, which is defined in the interface. And there is a return type, and the function returns a string. And the greet function uses template literal to construct a greeting message that includes the name and the age properties of the user. So there is an expected example output for user, because they already have the properties, the age and name properties, which are the name, which is Alice, and age 30. So we could reasonably infer that the expected output would be, hello, Alice, you are 30 years old.
The C++ side of things, it'll be like creating a function in you normally would in C++. String greet, taking in the variable user and then the structure user. It'll put out return user.name, which will return, it will say hello, the user's name, UR, and then the user age. And then, just like in Visual Studio Code, we're looking at like the TypeScript code, we're looking at the valid user getting the correct typing for the structure user.
For the third parts of the code in TypeScript, we see that it's the correct usage, and obviously there's a valid object assignment to this. The object's valid user is created and assigned the user type. It correctly has the required property, which the name, which is the string, and the number, and then a function is called the Greek function, and we have the valid user as the argument, which is the type of user. The function will successfully executes and return the greeting message.
This is a great example of showing us the advantages of static typing in TypeScript. We can see that the code will catch the error for trying to put in a string literal into the number literal, showing how it can be useful, but also allowing us to pass in new data into the user interface. Moving on from the demo, we're going to look at real-world use cases of TypeScript.
So we're talking about some of the real-world use cases of TypeScript. And the first one I'll be pointing out is one of the large-scale front-end apps like React or Angular and Vue. Basically, in front-end development, TypeScript provides numerous benefits, especially in large-scale applications where maintaining the code base can become very difficult without proper structure and tooling. For example, React TypeScript offers type safety. It just allows developers to define types for props, and it just ensures that the companies receive the correct types of data for errors. TypeScript also offers tooling support, like IDEs like Visual Studio Code offer auto completion and intelligence and stuff, which just make development faster and less error prone. I feel like a real world benefit would be like in a large React app, components can be deeply nested, and TypeScript helps ensure the right data flows between them, reducing the chances of bugs. And another real use case I can point out is backend development with stuff like Node.js, for example. Node.js is a popular backend framework, which is built on JavaScript, and obviously TypeScript can be seamlessly integrated to provide better structure, type safety, and just all-around developer productivity. And it's widely used in production environments for building APIs and type services and whatnot. So obviously, for example, with Node.js, TypeScript offers type safety, like I've said before, and scalability, because TypeScript is perfect for large backend applications and scalable and maintainable code. And then just the tooling and ecosystem in TypeScript is just works well with popular Node.js library. It just helps with type checking and error reporting. So I feel a real world benefit in large backend systems. TypeScript ensures that API requests and responses are structured correctly, and this reduces bugs that may arise from unexpected or ill-informed data, and developers can just also create a more complex logic with greater confidence.
Another great use of TypeScript is, since its wide adaptation and adoption, is it has a lot of libraries and software development kits, or SDKs, which allows for easier updating of larger databases or code bases and for easier development. To sum up the whole thing, TypeScript adds structure to JavaScript with its type safety and static typing and ease of use. It also allows for earlier bug catching thanks to its compile time error catching rather than runtime like JavaScript. And since it's just a superset of JavaScript, it's easy to adopt if you know JavaScript, and it allows you to learn JavaScript with more safety around it. It is also the more used system in JavaScript-based projects. As we've said many times at this point, it just adds safety to JavaScript. Thank you all for your time. Have a great day.